Okay, so my name is Leila Nóbrega Souza. I'm a PhD in TUE Eindhoven. And yeah, I started my PhD 3 years ago, and then I'm working in the CP10 project.
Thanks. So my name is Kathrin Scholbach. I'm an assistant professor at the Technical University of Eindhoven. Yeah, I work together with Leila in the CP10 project.
Hi, my name is Emmanuel Gallucci. I'm the head of research for cement-based material for Sika Technology, which is a mixture company. And I'm the mentor. I'm one of the mentors for CP10.
Okay, so the CP10 project, we are using recycled concrete fines, which is generated during the crushing of concrete waste. And in this project, we are approaching different treatments to improve the properties of these fines, so we can, in the future, reuse these fines in new cement-based materials.
I think this project is extremely relevant for all the construction industry, not only the cement industry, in the sense that it copes with, to some extent, circular economy, right? You have concrete structures which have a service life, then they have to be demolished, and the question is how do we manage that waste and what are the streams? And the question there is how can we reuse this waste into new building materials with optimized performance. So that's more connected to circular economy and management of the waste rather than pure CO2 emissions, I would say.
Basically, the future, how can we apply, as Katrin mentioned, how can we apply this material in large scale, because we have a lot of challenges involved. And yes, of course, we will keep our network, and both with the university and the industries.
Okay. I think from the industrial perspective, I mean, Core Project 10 is a collection of 5 different PhDs, which we have to see to some extent to some kind of screening, right? There are different approaches, and for the industry this is interesting because then that helps us mapping a bit what are the different solutions that can be implemented. That will depend on the national regulations, on the different environments. So that's the first step of the work, I would say. And,
yeah. So yeah, I would also say the application then. So previously we've done lots of characterization, small scale treatment tests, for example, or looked into reaction mechanism, and now it's really time to apply it in concrete and then see what the final properties are. And also look into durability and these things, because that's of course extremely important. So that cooperation is extremely important because we in academia, we need that input in order to come up with realistic solutions, because the big impact in the end will be made by the industry if they are able to use these materials in a large scale. And yeah, the input, the help is extremely crucial. So in the cooperation, we are supplied with the materials that we work with, so the realistic materials, not just small quantities we may be able to make in the lab, and to also receive advice on what to test, how to test. So we also benefit very much from the technical knowledge that is at the companies. And at the same time, we at universities, we have also a bit more freedom to play around with things that are maybe not as possible at the companies.